Hello and welcome back to Engineers Olympiad. We are going to start a new series for the subject Geotechnical Engineering. This is the MCQ series. This series is very exam focused practice wherein we'll try to solve as many questions for the subject as possible. We'll be solving the MCQ questions, the one-line answers and numericals for each and every concept and topic. So let's start. So the first question is, soil is defined as uncemented aggregate of mineral grains and decayed organic matter, cemented aggregate of mineral grains and decayed organic matter, consolidated material which is composed of solid particles produced by disintegration of rocks, or none of the above. All right, so we have the first question and we have to tell which option is feasible. So as we know that soil is defined as the uncemented aggregate of mineral grains, I write it over here. All right, soil, it is defined as the uncemented aggregate of mineral grains and decayed organic matter which is the solid particles all right, with liquid and gas in the empty spaces between the solid particles. All right, in empty spaces between solid particles. So this is the definition of soil. It is defined as the uncemented aggregate of mineral grains and decayed organic matter, that is the solid particles, with liquid and gas in between the empty spaces, all right, which is the spaces between the solid particles. It is filled by liquid and gas, and it is defined as an uncemented aggregate of mineral grains and decayed organic matter. Also, we can say that this soil in soil engineering, it is defined as an unconsolidated material which is composed of solid particles produced by the disintegration of rocks. All right, so soil is defined as the uncemented aggregate of mineral grains and decayed organic matter with liquid and gas in empty spaces between solid particles, or it can also be defined as the unconsolidated material which is composed of solid particles produced by the disintegration of rocks. So now let's get back to the question and see which answer is feasible. All right, so soil is defined as uncemented aggregate of mineral grains and decayed organic matter. True. Cemented aggregate of mineral grains and decayed organic matter. No, soil is not the cemented aggregate of mineral grains and decayed organic matter. It's rather the uncemented aggregate of mineral grains and decayed organic matter. Consolidated material composed of solid particles produced by disintegration of rocks? Not really. Soil is the unconsolidated material composed of solid particles produced by the disintegration of rocks, and the last option is none of the above. So the correct answer is soil is defined as, let me get back to this over here. All right, so soil is defined as uncemented aggregate of mineral grains and decayed organic matter. All right, now let's move to the question number 2. All right, so question number 2 is the empty spaces between the solid particles in soil contains liquid only, gas only, both liquid and gas, none of the above. All right, we already learned here that soil is defined as the uncemented aggregate of mineral grains and decayed organic matter with liquid and gas in the empty spaces between the solid particles. So the empty spaces between the solid particles in soil contain both liquid and gas. All right, let's move to question number 3. So the question number 3 is, a natural aggregate of mineral particles which is bonded by strong and permanent cohesive forces is called a. The answer is rock. A natural aggregate of mineral particles which is bonded by strong and permanent cohesive forces is called a rock. All right, let's move further. All right, question number 4. The word soil is derived from. The word soil is derived from a Latin word solium, which according to dictionary means the upper layer of the earth. The upper layer of the earth, which may be dug or plowed. All right, specifically the loose surface material of the earth in which the plants grow. So this word soil is derived from a Latin word solium, which according to the dictionary means the upper layer of the earth, which may be dug or plowed, or specifically the loose surface material of the earth in which the plants grow. All right, moving on. Question number 5. The material which is called as mantle or regolith in geology is known as soil in soil engineering. Is this statement true or false? This statement is true. All right, we have various connotations for the subject soil or soil engineering. So the material which is called as mantle or regolith, this is the nomenclature in geology. The nomenclature in soil engineering is the same material is called as soil over there. All right, so the material which is called as mantle or regolith in geology, that material is known as soil in soil engineering. This statement is absolutely true. Moving on to the next question, we have been asked to match the following. All right, so we have 3 different subjects from the left side: soil mechanics, soil engineering, and geotechnical engineering, and we have to match them to their correct terminology. All right, so we know that the soil mechanics is the branch of science that deals with, let me write it over here, soil mechanics. All right, soil mechanics is the branch of science that deals with the study of physical properties of soil, and the behavior of soil masses subjected to various types of forces. This is the definition of soil mechanics. Soil mechanics is the branch of science that deals with the study of physical properties of soil and the behavior of soil masses subjected to various types of forces. All right. Whereas soil engineering Soil engineering is the application of the principles of soil mechanics to practical problems. This is the application of principles of soil mechanics to practical problems. Whereas geotechnical engineering, it is the subdiscipline of civil engineering that involves natural materials found close to the surface of earth. All right, so let's move back and study. So soil mechanics, as already discussed, it is the branch of science that deals with the study of It is a branch of science that deals with the study of physical properties of soil and the behavior of soil masses subjected to various types of forces. This is the definition of soil mechanics. Soil engineering, it is the application of principles of soil mechanics to practical problems. Whereas the geotechnical engineering, it is the subdiscipline of civil engineering that involves natural materials which are found close to the surface of the earth. All right, and we can also say that this geotechnical engineering, it is a quite broad term which includes soil engineering, rock mechanics, and geology also. All right, so this geotechnical engineering, this includes, I write it over here, this is a broader term which includes soil engineering. It also includes rock mechanics and geology. All right. So this was the definition of these three things: soil mechanics, soil engineering, and geotechnical engineering, wherein we learned that soil mechanics is the branch of science that deals with the study of physical properties of soil and the behavior of soil masses subjected to various types of forces. Whereas soil engineering, it is the application of the principles of soil mechanics to practical problems, and geotechnical engineering, it is the subdiscipline of civil engineering that involves natural materials found close to the surface of the earth, and it's quite a broader term which is inclusive of soil engineering, rock mechanics, and geology. All right, let's move to the question number 7. We have to label the diagrams given below as nomenclature in geology or soil engineering. All right, we have been given two diagrams over here. All right, so we have two diagrams. This is the rock and this is soil. All right, and this is the ground surface. So the portion over here, it's rock. As you can see, it's written, it's rock. The portion from this rock to the ground surface, this is known as mantle or regolith. And whereas this layer, which is only some at some depth, the top surface, which is known as the soil. All right, so this nomenclature, wherein we call this part from the bedrock to the top surface, ground surface, mantle or regolith, this nomenclature is in geology. All right, so this is the nomenclature in geology. And if we move to the second diagram, which is this is the rock. All right, the portion from the rock to the ground surface is known as soil, whereas the top layer, which is only at some depth, the upper surface, that is known as topsoil. This is the nomenclature used in soil engineering. All right, so this was about, we had the cross section through the earth's surface, and we gave the correct designations as to nomenclature in geology or soil engineering. So the material which is called as mantle or regolith in geology is known as soil in soil engineering. All right, so once again, this is the terminology in geology, wherein this is the rock surface, and the portion from the rock to the ground surface is known as mantle or regolith, with the top area which is only at some depth, that is known as soil. Whereas the nomenclature in soil engineering, this is the bedrock, and this portion from the rock to the upper ground surface is known as soil, and the portion which lies at some depth at the surface of the ground, that is known as topsoil. So this was about the nomenclatures in geology and soil engineering. All right. All right. Let's move forward to question number 8. So the question number 8 is the natural slope of soil at which it remains stable without sliding is called as. We have to say what it's called, and it's also the steepest angle with the horizontal at which a pile of soil or loose material can stand without collapsing. All right. So the natural slope of soil at which it remains stable, that too without sliding, this is known as angle of repose. All right. So the natural slope of soil at which it remains stable, and that too without sliding, this is known as the angle of repose. All right. And it's the steepest angle with the horizontal at which the pile of soil or loose material can stand, that too without collapsing. All right. Let's move further. Question number 9. Question number 9 says the natural slope of clean, dry sand and ordinary earth are. The natural slope of, that means the angle of repose of clean, dry sand and ordinary earth are 31 degrees and 45 degrees respectively. All right. So these are the natural slopes of clean, dry sand and ordinary earth. All right. Moving on to question number 10. Geotechnical engineering includes soil engineering, rock mechanics, geology, all of the above. As we already discussed, this term geotechnical engineering is the subdiscipline of civil engineering that involves natural materials found close to the surface of the earth. All right, as already discussed. And I told you that geotechnical engineering, it's a broader term which includes soil engineering, rock mechanics, and geology. So the answer is all of the above. Geotechnical engineering includes soil engineering, it includes rock mechanics, and it includes geology as well. All right. All right. Next question. Question number 11 is who is known as the father of modern soil mechanics? All right. The father of modern soil mechanics is none other than Dr. Carl von Terzaghi. All right. So the father of soil mechanics is Dr. Carl von Terzaghi. He did a lot of research on the subject especially when his book Erdaubbaumechanik was published in German in the year 1925. All right. Let's move forward. The term soil mechanics was coined by the same person, Dr. Carl von Terzaghi. All right. So this term was coined by Dr. Carl Terzaghi in the year 1925 when his book Erdaubbaumechanik, I think this is the next question. The consolidation theory was published in Terzaghi's celebrated book. This book is known as Erdau Erdbau. I'll drop it down. All right. This is Dr. Terzaghi's celebrated book. It's known as Erdbaumechanik, and this was entirely on the subject of soil mechanics, and this was published in the year 1925. And in this book, Dr. Terzaghi coined the term soil mechanics. All right. So this term soil mechanics was coined by Dr. Terzaghi when his book Erdau on the subject was published. It was published in German and in the year 1925. All right, so most of the initial research on the subject was done by none other than Dr. Carl von Terzaghi. All right, moving further, we have the next question. The question is the International Society of Soil Mechanics and Foundation Engineering, known by the term this ISSMFE, was held at. We know that the first conference of the International Society of Soil Mechanics and Foundation Engineering was held at. It was held at the Harvard University. Harvard University in the year 1936 with Dr. Terzaghi presiding. All right, so the first conference of the International Society of Soil Mechanics and Foundation Engineering, ISSMFE, was held at Harvard University in the year 1936 with Dr. Carl von Terzaghi presiding. All right, next question. Question number 15. Who said this? These are some lines. Few people during Terzaghi's lifetime would have disagreed that he was not only the guiding spirit in soil mechanics, but that he was the clearing house for research and application throughout the world. We have to say which scientist quoted these lines, that few people during Terzaghi's lifetime would have disagreed that he was not only the guiding spirit in soil mechanics, but that he was the clearing house for research and application throughout the world. These lines were said by Ralph Peck. He was also one of the scientists who has also done a lot of research on the subject. These lines were said by him, Ralph Peck, in the year 1985. All right. Such was the fame of Dr. Terzaghi and his initial research on the subject of soil mechanics, that he said that few people during Terzaghi's lifetime would have disagreed that he was not only the guiding spirit in soil mechanics, but that he was the clearing house for research and application, and that too throughout the world. All right, moving on. Next question. Soils are formed by physical disintegration of rocks, mechanical weathering of rocks, both A and B, none of the above. We know that soils in soil engineering, it is defined as the unconsolidated material which is composed of solid particles, all right, produced by the disintegration of rocks. So it can be produced by soils, they can be produced by physical disintegration of rocks and mechanical weathering of rocks, both. So the correct answer is both A and B. Soils are formed by physical disintegration of rocks and mechanical weathering of rocks as well. All right, moving on. Question number 17. Question number 17 says, if the soil stays at the place of its formation just above the parent rock, it is known as. If the soil stays at the place of its formation just above the parent rock, it is known as residual soil. All right. If the soil stays at the place of its formation just above the parent rock, it is known as residual soil. We know that soils are formed by mechanical weathering of rocks due to mechanical disintegration or chemical decomposition or physical disintegration of rocks. You can also say that. All right. So if this disintegrated material, if it stays near its parent rock and does not move with some agencies of transportation to some other place and stays there only, then this soil is known as the residual soil. Moving on. Question number 18. And the question number 18 says, when the products of erosion of rocks are picked up by the agencies of transportation, and some agencies of transportation in case of soils, it can be water, it can be wind, it can be gravity, it can be glacier, or it can be the combined action of all these four. All right. So when the products of erosion of rocks are picked up by the agencies of transportation such as water, wind, gravity, glacier to new locations, and where they get deposited, which is away from their place of origin or away from their place of their parent rock, those soils are known as transported soils. All right. So the soil, if it stays at its place of formation just above its parent rock, it is known as residual soil or sedentary soil. And if it gets transported by certain agencies of transportation and gets deposited at a far place which is quite away from its parent rock, then this soil is known as transported soil. All right. Moving on to question number 19. Residual soils have relatively coarse material near the surface, relatively fine material near the surface, fragments of stones at greater depth, they are uniform throughout. We have to choose the correct answer. We know that the engineering properties of residual soils vary considerably from top layer to the bottom layer. They have gradual transition from relatively fine material near the surface, fine material near the surface, to large fragments of stones at greater depth. Large fragments of stones at greater depth. All right. And the properties of the bottom layer resemble that of the parent rock, and the thickness of the residual soil formation is generally limited to 5 meters only. So we have to choose the correct answer. They have relatively, residual soils have relatively coarse material near the surface? No. They have relatively fine material near the surface? That's true. They have fragments of stones at greater depths? True. They are uniform throughout? No, they are not uniform throughout. They have fragments of stones at greater depth and they have relatively finer material near the surface. All right. So this is some of the properties with regard to the residual soils, which are the soils which stay at their place of formation just above the parent rock. These soils are known as residual soils or sedentary soils. All right. So the engineering properties of residual soils vary considerably from the top layer to the bottom layer. So they are not uniform throughout. They have gradual transition from relatively fine material near the surface, all right, to large fragments of stones at greater depth, all right. But the properties of the bottom layer, it resembles that of the parent rock. The properties of the bottom layer in case of the residual soils, they largely resemble the properties of the parent rock from which these soils are formed, all right. So let's move on to question number 20. The properties of the bottom layer in case of residual soils resemble that of the answer is parent rock. All right, so this was about the engineering properties of the residual soils, wherein we see a gradual transition from relatively fine material near the surface to large fragments of stones at greater depths, and the properties of the bottom layer resemble that of the parent rock in many aspects. All right, and the thickness of the residual soil formation, as already discussed, is generally limited to a few meters only. All right. Let's move to the question number 21. The engineering properties of transported soils are, we have certain options and we have to tell which one is the feasible. All right. The engineering properties of transported soils are entirely different from the properties of the parent rock. At the place of its deposition. All right, so at the place of deposition we can see that this transported soil, its properties are entirely different from the properties of the parent rock. And the deposits of transported soils, they are quite thick and they are usually uniform. The deposits of transported soils, they are quite thick and they are usually uniform. All right, and most of the soil deposits with which a geotechnical engineer has to deal, they are not residual or sedentary soils, they are transported soils. All right, so let's get back to the question and see which answer is feasible. The engineering properties of transported soils are that their properties are entirely different from the parent rock. Deposits of transported soils are quite thick. Deposits of transported soils are uniform, all of the above. The answer is all of the above, as we learned that the engineering properties of transported soils are entirely different from the properties of the rock at the place of deposition. Deposits of transported soils are quite thick and are usually uniform, and most of the soil deposits with which a geotechnical engineer has to deal are the transported soils. All right, so this was about this question. Let's move forward to question number 22. Question number 22 says most of the soil deposits with which a geotechnical engineer has to deal are residual soils, transported soils, both A and B, none of the above. We know the answer, it's B, transported soils. Most of the soil deposits with which a geotechnical engineer has to deal are the transported soils. All right, which are transported from their place of origin to some other place that's known as place of deposition by the agencies of transportation. That can be wind, that can be water, that can be gravity, that can be glacier, or the combined action of all these four. All right. Next question. What are some agents or agencies of transportation of soils? Water and wind, glaciers and gravity, both A and B, none of the above. The correct answer is C. The correct answer is C. Both A and B, we know that the agencies of transportation for the soils, it can be water, it can be wind, it can be glacier, it can be gravity. All right, moving on. Question number 24. Question number 24 says, physical disintegration or mechanical weathering of rocks occur due to which physical process? All right, we know that soils are formed by physical disintegration or mechanical weathering of rocks and chemical decomposition as well. But here in this question, we have been asked that the physical disintegration or mechanical weathering of rocks occur due to what physical processes? Temperature changes, wedging action of ice, spreading of roots of plants, abrasion, all of the above. The answer is all of the above. All right. So the physical disintegration or mechanical weathering of rocks occur due to temperature changes, due to wedging action of ice, due to spreading of roots of plants, due to abrasion. All right. But we must know that in all the processes of physical disintegration, there is no change in chemical composition. There is no change in the chemical composition. All right, and the soils formed by physical disintegration or mechanical weathering of rocks, they had the properties of the parent rock, and coarse grained soils such as gravel and sand, they are formed by physical disintegration. All right, so the soils formed by the physical disintegration or mechanical weathering of rocks are coarse grained soils, gravel, and sand. And in all the processes of physical disintegration, there is absolutely no change in the chemical composition, and the soil has the properties of its parent rock. And the some of the things which happen during physical disintegration or mechanical weathering of rocks, it can be temperature change, vegetation of ice, spreading of roots of plants, and abrasion. All these processes lead to the physical disintegration or the mechanical weathering of rocks, and we get these soils, coarse grained soils, gravel, and sand, in which there is no change in the chemical composition, and the soil formed has the properties of its parent rock. All right. Moving on to the next question, question number 25. In all the processes of physical disintegration, there is no change in the chemical composition. The soil formed has the properties of the parent rock. Coarse grained soil such as gravel and sand are formed by the process of physical disintegration, all of the above. The correct answer is all of the above. As already discussed, in all the processes of physical disintegration, there is absolutely no change in the chemical composition. The soil formed has the properties of the parent rock. Coarse grained soil such as gravel and sand are formed by the processes of physical disintegration or the mechanical weathering of rocks. So the correct answer is all of the above. Moving on to the next question. All right. In all the processes of chemical decomposition or chemical weathering of rocks, we have to say which one is the feasible answer. Original rock minerals are transformed into new minerals by chemical reactions. Soils formed do not have the properties of the parent rock. Chemical decomposition of rocks results in formation of clay minerals which impart plastic properties to soils, and clay soils are formed by chemical decomposition. And the last option is all of the above, which is true. As we know that the soils are formed by either the physical disintegration or the mechanical weathering of rocks, or the chemical decomposition or the chemical weathering of rocks. And in this process, the chemical decomposition, the original rock minerals are transformed into new minerals by chemical reactions, and the soils formed by this process, they do not have the properties of the parent rock. And this chemical decomposition of rocks, it results in the formation of clay minerals which impart plastic properties to soils, and clay soils are formed by chemical decomposition or the chemical weathering of rocks. So all of the above is the correct answer, because all the options are correct. Yes, it's true that during the process of chemical decomposition, original rock minerals, they are completely transformed into some new minerals by means of certain chemical reactions, and the soils formed by this process, they do not have the properties of the parent rock, unlike during the physical disintegration of soils or the mechanical weathering of soils. And the chemical decomposition of rocks, this results in the formation of clay minerals. Yes, it's true, it results in the formation of clay minerals which impart plastic properties to soil. It's true. And clay soils are formed by chemical decomposition. Yes, it's true that clay soils are formed by the chemical decomposition or the chemical weathering of the rocks. And as we already learned before, that the coarse grained soils such as gravel and sand are produced by the physical disintegration or the mechanical weathering of the rocks. All right, so the correct answer is all of the above. All right, so this was something about the chemical weathering or the chemical decomposition of rocks and the formation of clay soils thereof. All right, question number 27. Question number 27 is, during chemical weathering of rocks, what processes take place? Hydration, carbonation, oxidation, solution, hydrolysis, or all of the above? The answer is all of the above. During the processes of chemical weathering of the rocks, the certain chemical reactions take place. Yes, it's true that hydration takes place, carbonation takes place, oxidation takes place, solution takes place, and hydrolysis also takes place. And then there is the rise of the clay soils, or the soils which are produced by the chemical weathering or the chemical decomposition of rocks. In hydration, During hydration, water combines with the rock minerals and results in the formation of a new chemical compound. These chemical reactions cause a change in volume and decomposition of rocks into smaller fragments or particles. During carbonation, it's also a type of a chemical decomposition in which carbon dioxide from the atmosphere, it combines with water and forms carbonic acid. This carbonic acid reacts chemically with the rocks and cause their decomposition. During the process of oxidation, it occurs when oxygen ions combine with the minerals in rocks. All right. These oxygen ions combine with the minerals in rocks. All right. And this oxidation results in decomposition of rocks. It causes their decomposition, and this process is somewhat similar to rusting of steel, the process of oxidation of rocks. This process is somewhat similar to rusting of steel. And then comes the third reaction, solution, in which some of the rock minerals form a solution with water when they get dissolved in water. So the chemical reaction takes place in the solution and the soils are formed. In hydrolysis, it's also a chemical process in which water gets dissociated into H positive and OH negative ions, and the hydrogen cations replace the metallic ions such as calcium, sodium, and potassium in rock minerals. And the soils formed have a completely new chemical composition. All right, and the correct answer for this question is all of the above. That yes, during chemical weathering of rocks or the chemical decomposition of rocks, the processes such as hydration, carbonation, oxidation, solution, and hydrolysis take place. All right, moving further. Question number 28 is, all types of soils carried or deposited by water are known as. All right, so the answer is alluvial deposits. All types of soils which are carried and deposited by water, they are known as alluvial deposits. As we know that when the physical disintegration or the chemical decomposition of rocks take place, and then these soils get formed, they can either be there with their parent rock at the place of their formation, or they can get transported by certain agencies of transportation, and water is also one of the most important agencies of transportation. And if the soils are transported, carried, or deposited by water, those types of soils are known as alluvial deposits. All right. Next question is question number 29. Deposits of soil made in lakes are called as. Deposits made in lakes are known as lacustrine deposits. Lacustrine deposits. These are the deposits of soil made in lakes. All right. These are known as lacustrine deposits. All right. And these deposits are laminated or woved in layers. You must know that these lacustrine deposits, they are laminated or warped in layers. All right. Now we are moving to the last question of this video, question number 30. And question number 30 is, what deposits are formed when the flowing water carries soils to ocean or sea? What deposits are formed when the flowing water carries soils to ocean or sea? The answer is marine deposits. All right. So the deposits which are formed when the flowing water carries soils to ocean or sea, these deposits are known as the marine deposits. All right. These deposits are known as marine deposits. With this, we conclude this video lecture. Thank you for watching.